All right, so the first question is asking you, an interval estimate may or may not contain the true value, right, of the parameter being estimated. So what they mean about this? Usually, so if I am in the case of normal distribution, and they are talking about an interval estimate, all right? So an interval estimate probably, let's say we are stopping at 95%, right? So this is the confidence interval, right? So now, what the meaning of 95%? It means 95% of the data will fall in here, in this shaded area, naturally, right? The other 5%, they will fall naturally as well in these two tails. So really the true value that we are talking about, it could be either somewhere here, or somewhere here, all right? 95% of the time, you're gonna be within the red area, and 5% naturally, you're gonna fall in these two tails, all right? So the answer would be is true, all right? And why? Because 5% will not fall within the interval estimates, and 95% of the data will fall within the interval estimate, right? I hope that's explained it. So in this question number 2 here, he's asking you, when do you use the t distribution? And I think it's easier to figure out when do you use the z distribution, right? So let's compare them together, right? Versus t distribution. So the z distribution, we use it for two conditions. It has to be sigma, which is the population, standard deviation. So this sigma must be known, right? Known or given to you, right? Okay, so that's the first condition. There is a second condition here, and the n, which is the sample size, this n must be greater than 30. So they are the statement and. So they are two conditions. 1 and 2 has to be verified. Now, on the other hand, when do we use the t distribution? If one of these two conditions is broken, right? So usually if sigma, the same thing, is unknown, all right? So this is the first one, or we are not using and here. So whenever I use the or, it means one condition or the other. The second condition, it could be as well the n, the sample size, all right, is less than 30, right? So here I should include equal sign, and the second one here, it can be less than 30. So if I have a small size, if I have a small sample size, then I use a t distribution, right? So I hope you make a difference right now. So if one of the condition is verified under the t distribution here, I will use the t distribution, right? So either the sigma is unknown or n is small, less than 30. Now the z distribution is more restrictive. You need to have two conditions verified in order to use the z distribution. All right. I hope this is clear. So in conclusion, we can resume everything in this table if you want to remember it. right? So here, the standard deviation, as you see here, do you know the population standard deviation and what they mean about this? They need sigma, right? Okay, so sigma is known. If it is yes, then you ask a second question. The sample size is greater than 30. If it is yes again, then you're gonna go to Z table. If any of the answers, any of the answer of these two questions, you're gonna be a no, you're gonna use the T table instead. So you can be halfway and use a T table instead. So either the sigma is unknown or the n is less than 30. All right. This. All right. So number 3A. So first of all, what is the critical value, right? So critical value is usually used whenever you are doing hypothesis testing. So after graphing your bed shape and having in the middle here 0, what you want to do, you want to graph the H1, all right? So supposedly here your H1 is two-tailed, all right? So supposedly the H1 is two-tailed. So what does mean? It means the alpha so it means the alpha is going to be split in two halves. So half of the alpha is going to go here and half of the alpha is going to be going there. And this is happening only for the two-tailed scenario, all right? So this is going to be alpha over 2 and this is going to be alpha over 2. In this case, alpha is 0.02 divided by 2, that's going to be 0.001, all right? Now, do you have to tell whether it is a T table versus Z table? Not really, because they are asking you here specifically for the T test. So they are restricting it to the T test, all right? So you know you are doing T test. On the other hand, from the previous question, we know if n is less than 30, you can again go to the T test. All right. So that's why we are using the T values, T table instead. All right. Now, once I specifically grab the alpha over 2 and alpha over 2, this is gonna determine where the cutoffs they're gonna happen. All right. And the cutoffs are gonna be where you're gonna reject 8.0, and from this side you're gonna reject 8.0. I don't really need to know all of this. I'm just explaining when do you use the critical values, all right? So there is another exercise coming up after that, supposedly, more work. So the critical values, they're gonna be on the T axis, and this is gonna be two critical values, all right? Because we have two tails, so we have two critical values. Now, how can we find the critical values? We need to use the T table, right? And what does require from you the T table? It requires two things, the alpha, which is, we know it, 0.002. And this is, you need to specifically say two tails. All right. If you want to talk about only one tail, you can evaluate one tail and what is it? So alpha one tail, it can be 0.001, which is this value. And you have to specifically say one tail. Only one tail, you're going to have 0.001. So either one of them, they're going to be on the same place anyway, right? So we need one of these two conditions. The second thing that you need a degree of freedom. So degree of freedom for the T table is always n minus 1, or n is 19, take away 1, that's going to be 18. So now, these two information, that's enough to go and use your T table. So what I get on the T table? I get my degree of freedom, all right? Just give me a minute, guys. All right, so we were saying that we need degree of freedom, which is 18, and that's the line of 18. It goes all the way. And if you remember, we said for one tail, it's going to be 0, 0, 1. For two tails, it's going to be 0, 0, 2. So I am going to follow this column over here. And you intersect the column with the row, corresponding row. And this is going to be that the value. So this value, it could be positive, it could be negative. I don't really know. All right. So I know the value is 2.552, right? So in order to determine positive or negative, I have to go to my previous chart. And I can see it here, the 0 is in the middle. So on the right side, I have two critical values. This is going to be a positive 2.552. And from the left side, it cannot be positive. So you're going to be negative 2.552. Finally, your conclusion should be the T critical. There are two of them. Either you separate them by comma, or you're going to put plus or minus 2.552. So this is going to be your answer. I hope this is clear. Okay, so for B here, they're asking you what is the critical value again, but they want to write tail, all right? So I need to graph it again. This is going to be my 0. The right tail is going to be on the right side. And this is going to be totality of the alpha, right? So alpha is going to be equals to 0.025. And this is only the value of one tail. They are not two tails, only the value of one tail, one side, all right? So whenever I need the information I need for the T table, I need first the alpha, and this is going to be 0.025, one tail. And the second information, I need degree of freedom, and that's going to be n minus 1, the n being 13. So this is going to be 13 minus 1, which is 12. And this is T critical over here, right? Now, let's follow with degree of 12. So this is 12. And one tail is 0.025. So this is one tail, and 0.025 is going to be right here, right? I do not care about the two tails here, right? So I keep only one tail, 0.025. Follow this column, follow this line. Both of them, they're going to intersect in 2.179. So I know the value. So here, the T value is going to be 2.179. This, it doesn't tell me it's positive or negative. It tells me only the value. And in order to determine whether it's positive or negative, I go to the chart. And you see it here is after the 0. The 0 is over here. This is after 0. So it must be positive, which is 2.179. And that's it. That's your answer. So now for the C, you're going to do exactly the same thing, but you're going to go on the left. So whenever you get the T value, you're going to get it negative, right? You get the value from the table, and you have to keep only the negative side. All right, I hope this one is clear. Let me know if you have any. All right, so if I'm doing A, I'm going to do A for now. So they are looking for Z critical, all right, critical value. needed to construct the 99% confidence interval. So every time they are saying confidence interval, you are in the two-tailed scenario. So you have to do your bell shape. You have to cut it on the right. You have to cut it on the left. So you are not going to end up with only one critical value. You're going to end up with two critical values. So this one and this one. All right. Now, what happened with this, the notation here, well, is a mix up between the Z alpha. So we know the Z alpha can happen only on the right side. Z alpha over 2, because this is alpha over 2. This is alpha over 2. So we know Z alpha over 2 is going to be only on the right side. However, if they are talking about the critical value, well, critical value, there are two of them, right? One here and one here. So there is a difference between Z critical is different from Z alpha over 2. So maybe this is going to be is a typo or anything, but they are not the same thing. So Z alpha or Z alpha over 2, this is always positive. And this one, it could be positive or negative, or one of them or both of them, right? Okay. Anyways, let's look for the value. So how are we going to do this? So if I know the 99% here, 0.99 in the middle, so 0 is here, 99% there. So whatever left is 0.01 divided by 2. So alpha is going to be always 1 minus C, C being the confidence interval. So 1 minus 0.99. And this is going to be 0.01. All right. So if I divide, this is the value of the alpha. If I divide by 2, this is going to be 0.005. So 50 basically, right? Okay. So now, okay. So now I have my 4 digits and I'm looking for 50 on the table. So what's going to happen here? I'm going to start looking from inside. And usually you look only for the small tail. So usually you look for this side only, left side. Okay, so I'm looking for the value 50, 50, 50. So 51 here and 49 here. So the value is going to be somewhere in the middle. So between 70 and 80, that's 75, right? Remember, there is a 0 here, 0 point. All right. And the other value, you can read it from this side. And that's going to be 2.5. So I am taking only the value, by the way. All right. So this is going to be the value in here. It's going to be basically, whenever you read it, is 2.575. So that's what I'm looking for. And that's basically it. So you're going to go. So right now, going back to the Z alpha over 2, if they are looking for Z alpha over 2, you're going to be 2.575, and it has to be positive. If they are looking for critical values, you're going to be plus or minus 275, 575. All right. And the reason why we, for the critical value, Z critical here, because on the right side, you're going to be positive, and on the left side, you're going to be negative. All right. Now, again, this is a mixed up in the question because they put both notations. But if you are looking for Z alpha over 2, this is going to be 2.575. That's the final answer. If you are looking for Z critical, it's going to be plus or minus 2.575. And I hope this is clear, right? Now, if you remember in class, I told you to use this table. You are allowed to have this table, all right? And you see the value, you don't need to sweat for it, is 99,2575. If you have a multiple choice, you want to choose the closest value to whatever value you have. So basically here, we solve all the problems by using this formula, all right, by having this table. The only one that missing is the last one, F. All right. And let's try to do the last one, F. So for F, I'm going to do exactly the same thing. So 75%. So if I have, this is the bell shape, this is the 0, I'm going to cut it off, half here and half here. And in the middle is 0.75. So your alpha is going to be 1 minus C, C being 0.75. And this is going to be 0.25. So this is your both alphas over 2. It can be 0.25 divided by 2. And this is going to be 0.125. And you can put a 0 there, right? And the same thing here, alpha over 2, it's going to be 0.1250, all right? Now, if you are looking for, all right, so if you are looking for Z alpha over 2, which is Z of 0.125, all right? You can put the 0. So you're going to go to your Z table again, box in here, and 1,250, right? That's what you're looking for. 1,250, and I think this is the closest one. All right, this is the value here. So what you're gonna do, you're gonna read it this way, is 1.1, and read it upward. That's 0.5, right? So the value you're looking for is 1.15. All right, and that's going to be the positive side. It's going to be your 1.15. So this is the Z alpha over 2, which is 1.15. Now, if you are looking for critical values, Z critical here, it's going to be negative 1.15, and Z critical is going to be 1.15. All right. Again, if you are looking for Z alpha over 2, you're going to be just the positive value, 1.15. If you are looking for Z critical, they are both of them plus or minus 1.15. Okay, I hope this is clear. Let me know if you have any question. All right, so we did this a couple of times in class. So we want to use the T value, the T table, sorry, to find the P value. All right, they give you the T, they give you degree of freedom, and they give you the two tails, right? So for A, let's see. Again, the way to do this is not precise. So you're going to be always putting the P value between two brackets, right? So now what is the P value? So if I have a T distribution here, and this is my 0, and T going to be 1.945. So T is going to be here, T 1.945. So where the T ends here, the tail is going to represent the P value. However, because here I am in two-tailed, all right? Because I'm in two-tailed, this is having another symmetrical p-value from this. So they are not only one side, they are two sides. And this is going to be therefore the p-value divided by 2, only half of it. And this is p-value divided by 2. So your p-value is the sum of these two. All right, I hope this is clear. This is happening always for two tails. It happened for the p-value, it happened for the alpha as well. Now, knowing this, I can, knowing the degree of freedom, which is n minus 1, 28 minus 1, which is 27, and knowing the t-value, it's going to be 1.945. So I want to determine what is the alpha or alpha. Well, it's not alpha, it's the p-value. All right, I want to determine what is the p-value. Okay, so what I'm going to do, I'm going to go to degree 27 first. I'm using the t-table, by the way. Just a minute again. Okay, so what we're going to do, we're going to go to degree 27 first. All right. So degree 27 is right here. And I'm going to follow this line until I find where this value 1.945 belong to, what interval. So you see here 1.945, you're going to be somewhere here, right? So now, how can I read it? I'm going to have to go up all the way and read the two tails intervals. So whatever falling behind, between, actually, I guess, right? So the two values are 0.1 and 0.05. So your p-value is going to belong to that interval. So first of all, be careful about the values. This is bigger. 0.1 is bigger than 0.05. So you're going to put 0.1 on the right and 0.05 on the left. And the p value is in between. All right. So this is your interval. Okay. Now, what the meaning of these values here? It means that the half of the p-value. So do you remember the tail that we were talking about? All right. So this half of the p-value, which is this area over here, it's going to be falling between 0.05 and 0.025. Now, the double of these two areas, it's going to be the yellow areas, 0.1 and 0.05. And that's all what we need. That's how you get this value. Okay. So this is the case of two tails. Now, for the case of one tail, let's go with the B. So B here again, we are using the t-table again, p-value for the test, and is 10U left tail. All right. So again, if we're gonna graph it, let's try to graph it first. All right, so 0 is here, and we are saying is a left tail, right? And do notice here that the value is negative anyway, right? So minus 1.145, minus 1.145. So this is the value on the t-axis. And this is the totality right now of the p-value. Whenever you are using one tail, that's going to be the totality of the p-value. All right. Two tails, only half. All right. This is left tail. All right, so again, what we need degree of freedom, which is n minus 1. And this is going to be 5 minus 1 is 4. And we need the t value, which is minus 1.145. And we're going to use the t table again. So let me clear this. So again, I'm going to follow on degree of freedom 4, which is this line. And then I'm going to look for the value 1.145. All right, I don't take the sign in consideration. And 1 point is going to be right here in the middle. 1 point, hold on. No, it's actually wrong. 1.145 can be somewhere here, which is very close to 1.9, right? But anyway, so you're going to be somewhere between this value and this value, 1.145. And again, what I'm going to do, I'm going to go up. Now, the difference before, I used the 2 tails, but now because I'm using only 1 tail, I'm going to go to the 1 tail value. And this is the 2 value that I'm looking for, between 0.2 and 0.15, right? So what you're going to have to do, be careful about 0.15 is smaller, right? So you're going to write down 0.15 here, the p value, and then 0.2 right here. And that's it. That's your answer. Okay. So that's going to be the p-value. Again, the table is not really precise. The calculator, there is a way to find the exact p-value. But for the table, that's the only thing you can do. You can just box the p-value. If it happens that you match exactly the same number on the corresponding degree of freedom, then you take that value. Otherwise, you always have to box it, right? Okay, so for question number 15, first of all, we need to identify whether this hypothesis testing is for dependent set or independent set. And my keyword is actually the before and after. You see it? So we have a before and after. So this is definitely dependent. Dependent samples. Now, both samples, if you count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they are 10, n is 10. If n is 10 is less than 30, and this is going to give you the t distribution. So everybody is clear why we are using the t distribution, right? Okay. Now, I need to find my claim. So my claim here is asking you all right, so the claim is right here. At the level of 0.05 significance level, test the claim that the mean score is not affected by the course. So what the meaning of not affected by the course? It means the mean before is equal to the not affected, right? So equals to the mean after. Isn't it? Not affected. Not affected means they are equals to each other, right? So starting with the state the hypothesis here and identify the claim. So the first step here, you're going to be the mean Well, this one is equivalent, right? The mean before equals to the mean after. All right, so this is before is 1 and 2 is going to be after, right? So this is in your book, we write it down as mu 1 equals to mu 2, all right? Or what you want to write down is mu 1 minus mu 2 equals to 0. And this is basically the mu d, right? What we call mu difference, all right? So your hypothesis H0 is going to be the mu difference is going to be 0. The opposite to this is mu d different than 0. This is going to be called H0. This is going to be called H1. And your claim happened to be H0 is the claim. Are we okay? So that's the first question, first part. The second part, what you want to do, you want to graph this. So I always graph H1. So how do you graph mu d is different than 0? You're going to go to this. You make 0 here. And this is going to be a two-tailed, right? Because it's different. So the meaning of two-tailed, it means this is going to be your cutoffs. And from here, reject H0. And from here, reject H0. Okay. Now, the alpha is given already, 0.05. So this is definitely half of the alpha. Alpha over 2, which is 0.05 divided by 2. And this is 0.0250. Okay. We are using the t-table, so it doesn't matter really alpha or 2 alpha, right? Now, the next step. All right, the next step, we want to figure out what is the T critical, right? And it happened here because these two tails, we have two T criticals. And obviously you're going to be positive and negative, right? Okay, for the T criticals, what you need degree of freedom. And that's going to be 10 minus 1, n minus 1, which is n minus 1, 9. And we need the alpha. The alpha should be enough. And that's going to be 0.05. I remember this is a two-tailed. Okay. All right, great. So we have degree of freedom 9. You're going to follow the 9. And you have two tails 0.05. So 0.05, two tails, you're going to be right here. So you're going to intersect this column and this line. And you're going to end up with this number. 2.262, right? All right, once you get the 2.262, you're going to go back to your chart. And you're going to notice that there are two of them. So one is positive, and the other one you can be negative. And that's going to be your T critical. There are two of them, which is plus and minus 2.262. All right, I hope this is clear. Now, the T-stat, how can I do this? And this I'm going to do it solely by the calculator, right? So let the calculator do some work. And let's see, how can we do this? Although here in the note, they give you D bar, that the average, and SD. But anyway, you are required to know how to find it, right? So let's go to the calculator. All right, so what you're gonna do first, you're gonna go to stat, you're gonna edit. So in L1, you're gonna put the before or the one. So you're gonna type in 74, 83, and so forth, right? So 88, 84, 63, 93, 84, 91, and 77. All right, so this was L1. In L2, you're gonna put the second values, which is starting with 73, 77, 70, 77 again, 74, 67, 95, 83, 84, 75. All right, so once you enter all the value there, what you're gonna go, to L3, but you have to click on the arrow up and enter. So you have to highlight the L3 and enter, right? So once you are there, you're gonna type in L1, which is second and one, minus second and two. That's L2, and enter. As soon as you put enter, L3 gonna be making the difference of the values, right? And then what you're gonna do is start again. You're gonna go to calculate. You're gonna go to one var, regular thing, right? We know how to do this. The only thing that's gonna change is instead of L1 here equals to the list in L1, you're gonna type in L3. So second and three. That's L3. Enter, no frequency, and calculate. All right, what do you need from here? You need the two values. So once you plugged in the calculator, you need the X bar, or what we call it. This is X bar, or X bar D if you want to, X bar difference. All right, and that's going to be 3.7. And as well, you need the SD, not the sigma, that's standard deviation, but for the sample, which is 4.945. Okay, so I need this value over here, and I need this value over here. Everybody okay? Now, in order to calculate the stat value, T stat, it's going to be the old formula, which is X bar minus the mean divided by S divided by radical N. So this is D, and this is D, and this is D. That's the only thing that had changed, but it's exactly the same old formula. All right. And in order to do this, the X bar, we know what is it, 3.7 minus mu D, please remember, is 0. And this is why 0, because you remember the hypothesis. This is your hypothesis. Mu D equals 0. So I assume mu D is 0, right? So this is going to be minus 0 divided by S. That's going to be 4.945. 0.945 divided by radical 10. And let's plug it into the calculator. So let's try to do it. All right, 3.7 divided by, open the parentheses, 4.945 divided by square root, second and squared, 10 here. Exit the square root and close the parentheses. Enter. So this is going to give me 2.366. Okay, so once I get that value, I'm going to go back to my chart. 2.366 is going to be somewhere after the 2.262. So this is T stat, which is 2.366. And you notice here is within the rejection zone. So your conclusion here, reject 80. And if you did reject 80, all right, we have evidence. Yes, for the evidence. And now, are we supporting the claim or not? We have to go back to the original problem. And the claim is actually 80. And since we rejected 80, we are not supporting the claim. All right, so do not support the claim. All right, so question number 5A, we are using the t-table here to find the p-value, and then basically they give you how many tails? Here, 2 tails. They give you the t-value, they give you the n, all right? So I think the best way to do this is start graphing it. So this is my t distribution, 2 tail. And this is the t-axis, right? Now, if I know is 2-tailed, it means the cutoff, they are on the right, on the left. And if they are 2 cutoffs, so this is going to be alpha over 2 here and alpha over 2. That's what happens usually for the 2 tails. And I don't really, I think I started this one wrong. Yeah. Okay, let me start it again. All right, so we have, this is my t distribution. And this is a 2-tailed, right? So now what happened is I'm going to locate 1.945. So let's say this is 1.945, which is the t-value, right? So what we call the p-value here, the p-value is the cutoff right here. So the tail that at 1.945, you're going to form on the tail, right? Now, this is one side. And because the fact that I'm having 2 tails here, it means there is a symmetrical one from the other side. And this is going to be your other p-value, right? So this is going to be only the half, of the p-value. And the other half is going to be over here. So your p-value is the sum of these two areas. All right. And this happens only for the two tails. All right. Now, what's going to happen here, you will need this p-value, all right? In order to get it, you need two things. You need degree of freedom, which is n minus 1, and that's going to be 28 minus 1, which is 27. And as well, you need the alpha value, all right? Well, we don't have the alpha value. That's going to be the p-value instead, right? So instead of using this, we're going to use the value t, going to be 1.945. All right. So how can I use it? I'm going to locate degree of freedom 27 first. So this is 27 right here. So this is the line of 27. And on this line, I'm going to locate where is 1.945. That's the t value, right? And it happens to be that the 1.945 is located right here on this band. So now, how can I read the alpha? Well, it's not the alpha, it's the p-value, all right? You have to go all the way up and read it. So now, because I am using two tails, I'm going to read the two tails one, right? Do not read the one tail. So your value, the p-value, is going to be located between 0.1 and 0.5. All right. I hope this is clear. So now your p-value, and this is the totality of the p-value, by the way, right? Because that's two tails, right? So you're going to be between these two values. And be careful here, 0.05 is smaller than 0.01, right? So 0.10, you're going to go here, and 0.05 goes here. And this should be your answer. Okay. I hope this is clear. Let's go for C. So how can I get C? This is A. So C, we're going to do exactly the same thing. I'm going to graph it. Here. So see, first of all, I graph my distribution. This is 0. This is the t distribution. And I am using C, right? So p-value, I have t going to be 1.34 and 30 and right tail. So the fact it is a right tail, the tail is going to be on the right. And this is your t value. T going to be equals to 1.34. And please remember, whenever you have left or right tail, it means you got the totality of the p-value. So here it's going to be, that's the complete value. We don't divide it into, all right? So this is my p-value there. So in order to find it, I need two things, degree of freedom, which is n minus 1. That's going to be 30 minus 1, which is 29. And I need the t value, which is 1.34. And use the table, of course, right? So I'm going to do almost the same thing. Let me clear the table again. All right, so I'm going to locate the degree of freedom 29. This is my band. And my value is 1.34, I think. T is going to be 1.34. And 1.34 is located between 1.311 and 1.699, and is closer to 311 as a matter of fact. All right. But anyways, as long as we don't get exact value, we're gonna put it between two parentheses, right? Two numbers. So my value is gonna be between this one and this one. So you're gonna be in the middle. You're gonna go up. And remember, you are not in the case of two tail, you are in one tail. So you're gonna read this, and the value that you're gonna read, these two, is closer to 0.1 rather than 0.05, but that's the values, right? So your p-value is between 0.01, no, 0.1 and 0.05. And please remember that this value is smaller, out with the right side smaller, right? So your p-value here is between 0.1 and 0.05. And that's basically it, how you find the p-value for one tail and two tails, right? All right, so here we are starting looking for the p-value at use 0.05 level of significance and conclude, all right, conclude the null hypothesis, right? All right, so they want you to find the p-value, so they don't want you to do the other way around. Although the other way around is easier, all right? Although from the, if you find the T critical here, is easier, all right? But anyways, let's do A. So A is a right tail, all right? So let's graph a right tail. Alpha is going to be totality here, all right? So this is the right tail, and alpha is going to be 0.05. So I don't really know the value of this, right? So I don't really know the T critical. It is easier to find the critical, as I said, but I don't know it. I'm going to do it with the p-value. So what is the p-value? I have the value is 0.052, right? So that's the Z value. So what I'm going to do, always please look at it in the small table. So what I'm going to do, I'm going to read it on small tail, 0.52. So 0.5 and 2. This is 0.5 and 2 is going to be this value here. So it's going to be this 0.3015. And because I have only one tail, the p-value, so again, what you have, Z equals to 0.52. And this is going to imply the p-value is going to be 0.3015. All right. And remember, this is one tail, right? So one tail, you read the value completely in there. Now, 0.315, and you have the alpha, it's going to be 0.5. And your formula is always p-value less than alpha. This implies reject. Otherwise, you accept, reject A0. So if I have this condition true, I will reject. So now what you're going to do is just verify it. The p-value is 0.3015. The alpha is 0.5. No, the alpha 005. My bad. So is it this inequality true or false? It's false, right? So if this is false, the conclusion, all right, you are not rejecting, you get the opposite. If this is false, you don't take reject 80. You do not reject 80. You got it? So in other words, I'm using the negation of this. Okay, so this is do not reject 80. So if you want to remember the formula, probably you can do it like this: p-value less than alpha, reject 80. If the p-value greater than alpha, do not reject 80. So this is the complete formula, right? Okay, and obviously for this case, we have the second one is valid, right? So we do not reject. I hope this is clear. Now, probably I should explain how do you get the critical value. This is done, by the way, right? So I can compare the p-values. If you get stuck and you didn't know how to do this, let's go with the traditional method. So alpha is going to be 0.05. That's a small tail. Add 2 zeros, that's 500. All right, you go to the z table. So you go to 500. And 500, you're going to be in between here, right? So you're going to be 1.6 between 4 and 5. That's 45, right? 1645. So this is, you're going to be z critical. You're going to be 1.645. And because you are on the right side, so you're going to be a positive, right? So this is positive. And you're done, basically. All right. So this is a separation. This is reject, 80. And this is do not reject. And because the statistical value, z, is going to be equal to 0.52. So there you go. You get your conclusion again. Do not reject. All right. So I hope this is clear. The remaining is the same thing. So you have to do exactly the same way, right? Okay, let's start. So they give you 6 numbers, and this is your sample. And what they are looking for, determine the 90 percentile confidence interval for the mean. All right. So what we did before, I'm going to use the formula of the error, E, all right? And the E, by the way, here we are using T distribution, right? I think it's clear. We have 6 numbers, n equals 6 is less than 30, so automatically it can be the T distribution. And you don't know the sigma neither, right? Okay, so the E is going to be sigma. Well, we don't have sigma. It's going to be S instead, divided by radical n times T alpha over 2, right? And this is your confidence interval. So if I have 90 in the middle, 0.90, this tails here is going to be whatever remaining divided by 2. So the alpha is going to be always 1 minus the confidence interval. and this is going to be 1 minus 0.9, which is 0.1. And this half of the tail is going to be alpha over 2. So it's going to be 0.1 divided by 2. And this is going to be 0.05. This is as well alpha over 2 is 0.05. So I hope this is clear, right? Now, the degree of freedom is needed, which is n minus 1, and that's going to be 6 minus 1, sorry. And 6 minus 1 is going to be a 5. And as well, you need alpha, and alpha is going to be, well, doesn't matter really, put alpha over 2 or alpha, as long as you know it's one tail or two tail. It's 0, 1, and two tail, right? That's the value in two tails. So now I can use the T distribution, T table, to find the T alpha over 2. Okay. And the T alpha over 2 is, well, it's supposed to be the right side. That's what you're going to get. But they are both of them, all right? So we're just going to take the positive one for now, right? All right, so let me grab the table, get back to you. All right, so degree of freedom is 5. I'm going to go to 5 right here. And then I'm going to look for 0, 1 for two tail, right? So two tail is right here. And I'm looking for 0, 1. And 0, 1 will be here. So I'm intersecting this column with this row. And the intersection is going to be this value, which is 2.015. Right. So the T alpha over 2 is 2.015. And because I'm using one of the tails, right? So this is positive 0.15. I just need the value. I don't need anything else. So now what I'm going to do, I'm going to calculate the error. Remember, the error is the distance from here to here. That's the error. This is E and this is E. So calculating the error is going to be S. Although we don't have the S, but they gave us the S here. I will calculate it in a moment. So this is going to be 4.976 divided by radical 6 times 2.015. Okay, so now I'm going to move to the calculator. I'm going to do two things. First of all, I'm going to show you how to find the S and how to find the X bar. I think you are familiar with it, but let's do it anyway. So we're going to look for these two values first, and then we're going to calculate the error, how much you're going to be, right? Let's start. Okay. All right. So the way to find the X bar and standard deviation, what you need to do is go to Stat, Edit, enter the number that you have. Well, I have some work there. I'm going to delete it. So I'm going to go to second and plus, that's memory, and then delete, clear all. All right, done. Now I'm going to go back to Stat here, Edit, and my table are empty. It's good. And let's put the numbers. So 77.9, enter, 89.1, enter, 80.7, enter, 78.6, then 74.4, then 82.0, right? Okay, they are the 6 numbers. I'm going to go to Stat again. I'm going to calculate right now. 1 var. Yeah, and make sure the list in L1, right? So I'm going to do second and 1, that's L1. No frequency and calculate. Okay, so the X bar, as you see it here, is 80.45. That's the same value that I got here. And the SX is 4.97624. So 976, 4.976, you should be fine. All right. So that's how you get the values, even if they don't give it to you as a hint, right? Now, I need to calculate the error. I'm going to clear everything. Let's start with 4.976 divided by radical 6. So second 6. And then exit the radical sign and multiply it by 2.015 and 5. Enter. So the value of the error is going to be 4.0934. Right, 0.93 is fine. Okay, so now how I'm going to do the confidence interval. So my confidence interval, which is the mean, is between the X bar plus the error and X bar minus the error. So please notice that I'm using exactly the same formula that I have here. All right. And what I did, I call this one the error. So this is X bar minus the error. This is the mean. This is X bar plus, and this is the same error, right? So that's what I'm using, right? Okay, so let's go back. Now, the mean will be X bar, we know it is 80.45. The error, we know it is 4.093. And here's the same thing, 80.45 minus 4.093. So let's do this minus 80.45. So the lower end is going to be 76.356, so 0.36. This is, and this we can add it, I think is easier. So you're going to be 84.5 and 4. Okay. And we can take the 3 away. So you're going to be, this is your confidence interval. You're going to be between 76.36 and 84.54. All right. And I think that's question A. Was going to, right? Yeah. So A is good, right? Determine the standard error of the mean. So standard error of the mean, we did it already. That's S. And I showed you how to do it. So also is given here is 4.976. The marginal error is done already. The marginal error, that's E. And E is going to be 4.093. We got it. How large the sample should be taken? All right, so to estimate 90% confidence interval within 2 points. All right, so what the meaning of within 2 points? It means the E here, it means the E is going to be equals to 2. And what they are looking for? They are looking for N. Or for this part of the question, we have the formula as well. And the formula that the sample size, right? So the N that you're looking for is Z alpha over 2. We don't have Z, we have T. T. Yeah. Yeah, I'm still going to use Z because we don't know N. So this is for large N. All right, so I'm going to multiply it by the sigma. I don't have sigma, so I'm going to multiply it by S and divide by E and square it. Now, the S is 4.976. The E, we know it, is 2. And this is Z alpha over 2. So what is Z alpha over 2? And we did not do it because we used the T before. So we need the Z table here, right? But still the same here. So this is what you're looking for. If you round to 4 digits, the alpha over 2, one tail, is going to be 500. All right. And you can use the confidence interval table. So I know this is 1.645 if you use the Z table. Just give me a minute. All right. So in order to make it easier for you guys, please have this confidence interval table. The 90% is 1.645 hours whenever you are dealing with confidence interval. So this is 1.645, right? And that's all. You plug it in, so you're going to be 1.645 times 4.976, square it, divide by 2. All right. Well, divide by 2 and then square it, right? All right, so let's try to do it. $1.645 times 4.976 divided by 2, enter, and square. So you're going to be 16.75. This is always rounded up, so you're going to be n equals 17. And the reason why we couldn't use the T table here, because we did not know the degree of freedom. So if we didn't know the degree of freedom, we couldn't decide, all right? So we had to use the Z values, okay? So no degree of freedom, the T table, you cannot use it. All right, so we said this is independent sample, all right, here. And what we're gonna do, we said as well, the N1 and N2, they are less than 30. So definitely we're gonna use the T table, right? So I hope this is clear. Now, we are looking for the claim. We're gonna use the level of 0.025, level of significance, to test the claim. So this is my claim that the mean resting pulse rate of people who do not exercise regularly is larger than the mean of the people who exercise regularly. So your claim, if I'm going to call this is mu1 and this is mu2, and this exercise regularly, and this is the people who do not exercise regularly. So this is going to be like this, right? The people who do not exercise regularly is larger, all right? So your claim is mu1 greater than mu2. And as we talk about it in class, you wanna move the mu2 to the other side. So this is going to be mu1 minus mu2 is greater than 0. And that's what we're going to call H1, right? H1 is going to be mu1 minus mu2 greater than 0. And H0 would be, by consequence, mu1 minus mu2 equals to 0, right? So this is my claim. Right, so this is stating step 1, right? Stating the hypothesis. Now, before going to the critical value, we need to graph it to know what we are doing. This is my bell shape, and this is 0, and you are greater than 0. So greater than 0, you're going to go on the right side. So this is your alpha, and this is right tail. And your cutoff, you're going to be right here. And from this side, you're going to be rejecting, right? Reject A0. Here, do not reject. Okay, so now step number 2, we want to find the critical value. So this is T critical. In order to get the T critical, I need to do the degree of freedom. So degree of freedom is going to be the minimum of the N between N1 and N2 minus 1, right? So the smallest value is 12. That's going to be 12 minus 1, that's 11. So that's your degree of freedom. Then you need the alpha. The alpha, they give to you here 0.025. And you need to mention is one tail, right? Okay, so the table requires one tail or two tails. So this is going to give you the value of the T. And let's go to the table. Okay, so here we are in 11. So this is my degree of freedom 11. And then we have 0.05, one tail. So one tail is right here. Locate 0.025, which is the value over here. So you're gonna follow this column and you extend this row, and both of them, you're gonna intersect in this value, 2.201. All right. Then you don't know whether it's positive or negative yet. You have to go back to your graph. And because you are on the right side, this is 0. So you're going to be 2.201. So your T critical is positive. Positive 2.201. All right, that's the second step. The third step, T-stat. And this is a formula. So let me grab the formula first for you. All right, so calculating the T-stat, plugging in the numbers. So X1 bar is 73, right? X2 bar is 68.4. Now, this value here is going to be a 0, minus 0, right? And then this is divided by square root. Now, S1 is this value here. So 10.9 squared divided by N1, which is 16. And then plus S2, which is 8.2 squared divided by 12. All right. Let's do it to the calculator. All right, so for the calculator here, we're going to start with the parentheses, 73 minus 68.4 close the parentheses, and divide right now everything under the square root, so I can skip the parentheses. Second squared, and then it can be 10.9 squared divided by 16, and then plus 8.2 squared divided by 12. Keep this. Okay, so that's going to be 1.27. Okay. So now once I get the t-stat, I'm going to go back and graph it. So the t-stat is going to be right here somewhere. Is 1.27. And you notice is within do not reject. So you're going to do right now, you step number 4. All right, step number 4 here. Conclusion is going to be do not reject 80. Step number 5, you're going to summarize. All right. And step number 5, if you did not reject, not enough evidence, no evidence. And here, are you supporting the claim or not? You did not reject, and you're saying the 80 is correct, so you're against the claim. Do not support the claim. So you are not supporting the claim and you do not have enough evidence. All right. And that's basically number 14. So this is question number 8. And what we want to do here, we want to figure out what is type 1 error for this scenario, right? So first of all, you need to write your hypothesis, all right, before defining the type 1 or type 2. So the claim here that the mean mileage of the, right here, the mean mileage for the Carter Motor Company's new sedan is less than 32 miles per gallon. So the way I'm going to write this, that the mean is less than 32, all right? And because this is no equal sign there, so I'm going to start with 8. Here, this will be H1, the mean less than 32. Therefore, H0 would be the mean equals to 32. I hope this is clear. Now, what type 1 error, what is it? Is basically type 1 error is reject the null hypothesis or H0 in error, right? What does mean in error? It means whenever you reject H0, you are making a mistake. So what is H0? All right. So here the fact rejecting H0, it means reject the fact that the mean equals to 32. And in fact, the mean actually is equal to 32. So you reject it, but whenever you check it, the mean is 32. So this is type 1 error, right? For our example. I hope this is clear. So first of all, you define H0 and H1. You go for the definition of type 1. You reject H0. So reject that the mean equals to 32. And that what you did is a mistake. All right. So that's a negation. All right, so number 9. So again, here we're gonna define the H0 and H1 whenever we can, and we are looking for type 2 error, right? So a company produces a refrigerator for beer kegs. All right, the refrigerator are supposed to maintain a mean temperature of 43 Fahrenheit. All right, so this sentence here. All right, so this sentence here claims that the mean equals to 43 Fahrenheit, right? Now, the claim is coming up. All right, the owner of the brewery does not agree, all right, does not agree with the company and claim that the mean temperature is incorrect. So what the meaning of that the claim? The mean is different than 43. So that's the claim. All right, this is what's the claim here. I input. All right, anyways, so this is H1 then. The mean is different than 43. All right, that's the claim. And because it's different, it's going to be nothing else than H1, right? Now I need to define H0 again, and that will be the mean equals to 43. So what is type 2 error right now? So type 2 error did not reject H0, and that is going to be in error again. So you are making a mistake by not rejecting it. You should have rejected it, but you are not rejecting it. So for this case, the H0 is right here. And what does mean do not reject? All right. So for you is do not reject. It means you are supporting, all right, or you thought, all right. You support the fact that the mean is equal to 43. That's mean do not reject H0, right? However, in fact, that is wrong. What does mean? It means the mean is different than 43. All right. You are thinking that the mean is equal to 43. However, the mean is different than 43. And that's what is type 2 error. All right. Already. So what we have here, this is a Minitab results, right? So what the meaning of this test is saying mu equals to 40. So that I'm going to write it over here, right? So mu equals to 40, that's going to be the mu equals to 40. And you are comparing it versus the mu not equals to 40, right? Not equals, right? And that it will be the mean different than 40. So this is by default, it's going to be H0, and this would be H1. I don't have any claim here, so, but that's how you read the first sentence, at least. All right. Now, n equals to 60, that's obviously n equals to 60. The mean, all right, so what the meaning of the mean equals to 3712, that it means x bar is going to be 37.12. Again, standard deviation is going to be 4.931745. That's the S or sigma. I don't have the sigma, I don't think so. So this is the S. It can be 4.931745. All right. The standard mean, and what they mean about this standard mean it means the E value. All right. And we can double check it. The E value, by the way, is X bar minus, no, that's T. That's going to be S divided by radical N times T alpha over 2. All right. Now, although we don't know what is T alpha over 2, because we are not given the alpha here, I don't see the alpha anywhere. So that's fine. We can double check it later. The alpha is not an output of the Minitab. All right. Now, the confidence interval, obviously, here the 95th percentile confidence interval, that the two boundaries, the lower and the upper. This is the t-test, t-value. So the t-value, t-stat, and the t-stat here is going to be equals to x bar minus the mean divided by sigma, which is S, divided by radical N. All right, so you are familiar with the formula, right? And from there, we're going to get the p-value, and this is the p-value, all right? Okay, so this is how you read the table, right? Now, we can start with A. The A is asking you, do you reject A0 or not at this level, right? So they are giving you the alpha, and they are asking you. So now here, this is the formula we agree on. So if I have the p-value less than the alpha, reject A0. If I have the opposite scenario, the p-value greater than alpha, do not reject. Please make sure you have this formula on your formula sheet. You are allowed to have it. And the only thing I need to do is I need to compare the p-value, which is this value here. So the p-value is 0.00040 zeros and 30. And the alpha value is going to be 0.01. So obviously, the alpha is greater, right? So I am in scenario number 1 right here. The conclusion can be reject 80. And that's letter A. All right. I hope this is clear. How many degree of freedom are there? So for B, degree of freedom, it can be always n minus 1. And since we have n equals 60, 60 minus 1, it can be a 59. All right, so we're done with letter B. We're going to look for the p-value of the interval given. All right, so C here, in order to check the p-value is right here, right? So your p-value that you're looking for, it can be equal to 0.000030. Okay. Now they are looking for T of alpha over 2 at 95% confidence interval. So this question, we can say, is independent from the Minitab output. So you just have to use the table, all right? So let's see. For D, what you need degree of freedom, all right? Degree of freedom is going to be n minus 1, which is 59. We got it. And what you need as well, you need the alpha. And the alpha is going to be always 1 minus the confidence interval. So for this case is 1 minus 0.95. And that's going to be 0.05. Now, every time you are doing confidence interval, this is a two-tail. And you need to specify here the alpha equals to 0.05, and you need to specify its two-tail. Okay, why do we need the two-tail? Because whenever you're going to use the table here, so obviously it's 59, degree of freedom 59. So you're going to be going to 60. I think 60 is the closest. And because you are using two-tail, all right, the two-tail is going to be right here, all right? So you're going to look for 0.05 in two-tail, which is this value. And that's going to be this column over here. And you follow through it. You extend the line of this one. And the value that you're looking for is going to be a 2, right? So for the T of alpha over 2, that's going to be T of 0.0250. That's the value in here, the top. That's alpha over 2. All right. And this one is going to be equals to 2.00. Okay. All right. So done with that one. Let me copy this. Okay. So we're going to do exactly the same thing for E. All right, so for question E, they are asking you exactly the same thing, T alpha over 2 at 98%, all right, confidence interval. So again, what you need to do, you need degree of freedom, and that's going to be n minus 1, which is 59. As well, you need the alpha value. The alpha value is going to be 1 minus the confidence interval. That's going to be 1 minus 0.98, and this is going to be 0.02. Don't forget that the alpha is going to be a two-tail. All right. Then you're going to go to the table and you cross them. So let's go here. Clear this. All right. So again, we're still in 60. That's the closest to 59. So you're going to be this line over here. And we are looking for 0.02 in two-tail. All right. So this is two-tail and 0.02 is right here. So you're going to follow through this column and extend this line, and the intersection is going to be 2.39, I think. Yeah, 2.39. The alpha over 2. And if you want to figure out what is alpha over 2, that's going to be alpha over 2 over here, right? So this is T 0.01, and that's going to be 2.390. Please note that every time they use this notation alpha over 2, all right, the number here is going to be positive. It cannot be negative. So it's always the right side. This is going to be here, right? So this is T alpha over 2. Always on the right side, right tail. Okay. Finally, F, they wanted to use the information to output the construction of 98% confidence interval. All right, so confidence interval, probably I should get to the formula. Give me a minute. Slightly different. All right, so if you want to use the formula, is right here. This is confidence interval, and this is the formula that you are using for the T value, right? Okay, so what we did here for F, we're going to calculate the for F here, we're going to calculate the E first. So the error first, and that's going to be the S divided by radical N and times T alpha over 2, right? And we have all the values here, so we can plug the mean right away. And the confidence interval that you're looking for, it can be the mean between the X bar minus the error and the X bar plus the error. So it is the same formula, right? The only difference here, we are calling this value in here, we are calling it E. So that's X bar plus E. And this value as well, we are calling it E. And that's the same value, by the way, right? So that's going to be X bar minus E from this side. This is the mean, and this is going to be X bar plus E, which is the error. All right. Okay, so let's try to do the calculation. All right. Now, the S, we said is this value over here, right? So it can be 4.931745. You don't need too many digits. I think 3 should be enough. The N is 60. And the T alpha over 2, because we are using 98 percentile, so we're going to use this value in here, right? So this is going to be 2.390. All right, calculator. All right, so let's do this. It can be 4.931. This I'm going to put them all, 745. I'm going to multiply it by 2.39. And then divide it by radical square root of 60. Okay, so you're going to be 1.5216, so 522. $1.5. So this one is going to be X bar. Again, the X bar is this value, 3712. So you're going to be 3712 minus, let's round it to 2 decimals. So minus 1.52. And the mean, and this is going to be 3712 plus 1.52. Okay, so let's do the operation. 3712. Okay, so this side you're going to be 35.598. That's going to be, right? So if I round the 2 decimals, that's going to be 35.60. And this part, we can do it, I guess. It can be 38.64. And that's all. That's going to be your confidence interval. Okay, so we want to figure out whether the samples are dependent or not. So which one are dependent, which one not. So what do you think about the weight of identical twins? They're usually identical twins, they depend from each other, yes? So they are practically almost the same thing. All right, so this is goes with dependent. Usually they eat the same food, they have the same DNA, they practice, if they have sports or whatever it is, the same diet, same exercises, right? So yes, they are dependent, right? All right, so the effect of drug on tumor size of two different groups of people measured by before and after. Every time you see before and after, they are dependent. All right. Number 3, the effectiveness of two different brands of antacid on two different group of people. And this is not dependent. So this is independent, right? So we are looking for as dependent samples. The 3 is not dependent. The 1 is good, 2 is good, 3 is not good. All right, the effectiveness of two different training programs on two different groups of individuals. And this is again, different and different, they are independent. All right, test scores of the same students. So they are saying the same students here. All right. In statistics and art. So different subjects, but the same students. And this is going to be dependent then. All right. All right. So 1, 2, and 5 are dependent. 3 and 4 are not. So what we have here, a public bus company official claimed that the mean waiting time for the bus number 14 during peak hours is less than 10 minutes. So this is my claim, right? Less than 10 minutes. If I write it down, it's going to be the mean less than 10. And because is less, strictly less, this is definitely H1. This is my claim, by the way. And I can identify as well H0, and that would be the mean equals to 10. So that's step 1, all right? Okay, this is the first step. We finish with step 1. Okay. So now we are coming up with more information. Karen took this bus number 14 during peak hours 18 times. So that's going to be the N, it's going to be 18. All right. Her mean waiting time was 7.8 minutes, and that would be the X bar. 7.8, 7.6, sorry, minutes. With a standard deviation, 2.3. So standard deviation here, 2.3. So whenever they are talking about standard deviation, they're talking about the 18 different occasions, right? So that's S, is not the population one, right? So that's 2.3 here. And then what we want to do at the level of 0.01, that's going to be the alpha, 0.01. We want to test the claim of here. We want to test the claim of the mean waiting time is less than 10 minutes, right? Use the p-value method of the testing hypothesis. So yes, kind of, well, they ask for the p-value method. So let's try to do the p-value method, right? Okay. All right, so step 1 is done. So once you get step 1, what you want to do as well, you want to graph it. So what you're graphing here, you're graphing H1. And this is basically 10 in the middle. and you are less than 10, so the tail is going to be this side. So always you graph H1, right? And the totality of the alpha, which is 0.01, is going to be here, and this is going to be your cutoff at this point. This point here is going to be the T critical. And of course, you are rejecting A0 here. And from the other side, do not reject, right? From here, do not reject. Okay, now this is the left tail if you need it. And from this one, we're gonna move on to step 2. And step 2, we wanna find the critical values, right? So step 2, after doing this, we need to identify that we are using the T table. So here is less than 30, and this is sigma known, right? So one of them is enough, by the way, this or this is enough to use the T table. So okay, so we identify the T table. What I need for T table, I need degree of freedom, which is n minus 1. And that's going to be 18 minus 1, and that's 17. And I need alpha as well. So the alpha is going to be 0.01. And you need to specify here is only one tail. So now you can use your T table. And to use the T table, we say 17. So 17 this line. And 0.01 in one tail. So you are looking for 0.01 in here. So you're going to be right here, right? So you're crossing this column with this line here, and your T value is going to be 2.567. Now, this is not my T critical. Why? Because I don't know the sign. All right. So supposedly here where the 10 at is going to be my 0, and this is my T values, and you are before the 0. So your T critical is going to be negative. It's going to be negative 2.567. Right. I hope this is clear. So let's conclude here. Step number 2. T critical is going to be negative 2.567. Okay. Hope this is clear. Now we are moving on to step number 3. And step number 3, they wanted to compute the test value. So here we are in the case of only one sample, all right? And for one sample, the T-stat, and we are using the T value, right? The formula is X bar minus the mean divided by S over radical N. All right, so I know the X bar is 7.6. The mean, I know it is here 10, all right? And divide by S, the S is 2.3, divide by radical 18. Right, so the calculator, All right, so start with the parentheses, 7.6 minus 10, close the parentheses, divided by, open the parentheses if you want, 2.3. And divide by square root of 18. Okay, I get the value of minus 4.427. All right. So now, oh, I didn't use the p-value method, but anyways, let me finish this. So I go back to my chart and place with these my t-stat. And the t-stat, it should be farther away here. So the t-stat is going to be negative -4.427. So you see here is within the reject zone, right? So step 4, you're rejecting 80. And step 5, you're going to make conclusion. So if you reject 80, yes, you have evidence. And are you supporting the claim or not? If you reject 80, so you are supporting the claim, yes. And I'm supporting the claim just because I am not, I mean, the claim is H1, all right, it's not H0. So if I reject H0, I am supporting H1, right? Okay, so now let me try to find the p-value, all right, and do it differently. So for the p-value, it's going to be exactly the same thing. The only difference here, let me grab the formula. All right, so if I follow the steps, since we did it already, so step 1, it's going to be 80, which is the mean equals to 10, and H1, and this is the mean, is less than 10, and this is the claim. I'm not going to graph it again, so probably I should. So this is your graph, and this is going to be your alpha, which is 0.01. Now, step number 2, compute the test value, right? So t-stat or test, we did it already, so it's going to be x bar minus the mean divided by s divided by radical n. And we have it there, that's going to be 7.6 minus 10 divided by 2.3 divided by radical 18. And this is going to give me minus 4.427, right? Step number 3, we're going to find the p-value. So what we are saying here, we are saying the t is equal to minus 4.427, and degree of freedom is actually n minus 1, which is 18. So I'm using the t table in reverse, right? So first of all, I'm gonna here, I'm gonna identify degree 17. So degree 17 is this line over here. And I have to keep extending it, all right, until I get a value of minus 4, I mean 4.427, right? So, and you notice here, this is this value here, all right? Don't worry about the minus sign, 4.427. So obviously 4.4.27, it can be somewhere here after the 3.9, right? 4.427, it can be somewhere there. So if you're gonna read the p-value, you gotta go up. And whenever you go up here for one tail, right? You're gonna be between this value and the next value over here, you can be 0, right? So 0.0000, right? So your p-value that you're looking for, it can be between 0.0000, and the other one is, I think, 305. Right, so it's going to be 0.000 and 5. Now, the decision that you're going to make, right? Remember the formula that we did earlier regarding the p-value and how do you make a decision, right? So your formula is p-value smaller than alpha, reject. P-value greater than alpha, do not reject. And obviously here the p-value is very small, so the p-value is almost 0. The greatest value is going to be 3, 0, and 5. The alpha is going to be 0.01, and obviously the alpha is greater, so I am in the first scenario, and that's going to be reject 80. So step 4, you're going to say reject 80. Step 5, if you reject 80, yes, evidence. And are we supporting the claim? The claim is H1. Yes, we support the claim. Okay, so that's how you solve it with the p-value, right? Really, if you don't know how to solve it with the p-value, use the traditional method. I will count it correctly either ways. Okay, so we are up to the last problem. We have about 5 minutes. Okay, stop recording. All right, so here at the level of significance 10%, that's the claim. So the claim here that the sample is from a population with a mean life of 900 hours. So what the meaning of this 900 hours, it means the mean equals to 900. All right. And here the claim again that the average life of light bulbs is, so is what the meaning of is equal sign, right? So do you see here the claim is not necessarily H1, right? So this is H0. Why? Because the mean equals to 900. That's going to be the claim. And H0 is always with equal sign. So H1 will be the negation of this, which is different than 900. And this is a two-tail distribution. So your cutoffs, they're going to be 2 of them. And each tail is going to contain alpha over 2. So if alpha is 10%, which is 0.1, this is going to be 0.1 divided by 2, which is 0.05. And this is going to be 0.05. That's one tail, right? So this is a two-tailed, and we're good. Now, we have 15, sample of 15 is less than 30, so you're going to be a t-test. And let's move on to step number 2. Step number 2, we need the T critical. And there are two of them, one here and one here because two tails. So this is assumed to be 0 here. And we have two values, right? So one positive, one negative. In order to do this, you need degree of freedom, which is n minus 1. That's 15 minus 1, which is 14. And you need the alpha, all right? The alpha is already given to you, is 0, 1. And don't forget, this is a two-tail. I think that's enough information to go to the T table. So degree of freedom, we say 14. That's 14 is right here. And for two-tail, we are looking for 0, 1, which is this value here, right? So you follow through this column, you extend this line, and that's the number you're looking for, the intersection, 1.761. Now, because you have two tails, one of them is going to be positive 1.761, and the other one is going to be negative 1.761. So your T critical is plus or minus 1.761. All right. Therefore, this is going to be your cutoffs. You're rejecting A0 on the sides, right? And do not reject in between. Okay. All right, so that's step 2. Step number 3, compute the test value. So the t-test is going to be equals to x bar minus the mean divided by s divided by radical n. Now, although they gave you here in the note, the x bar and the s, usually they do it as well on the exams, just in case you get stuck. But you can do it on the calculator. So let's do it together. You go to start and enter. So if you have the table full, you're going to go to second, memory, and you clear it. Clear all lists. Number 4, enter, enter, done. So you're going to go back to start, edit, and enter the number right now, right? So you're going to be 995, 590, 510, 539, 739, 917, 571, 555, 916, 728, 664, 693, 708, 887, then 849. Okay, once you enter all the number, they are 15. You're gonna go to start. You're gonna calculate right now. One value is the first one. Enter. Make sure this is the list in L1. All right. No frequency and calculate. So what you're looking for the X bar. And you notice here the X bar is 724, is similar to this value. And the SX 156.92. So they rounded to 157. All right. So we're gonna use these two values. All right. So that's in case they don't give you these values, you know how to get it, right? Using the calculator. Okay, so let's do this. This is the X bar, it's gonna be 724 minus the mean. The mean is 900, we said. Divide by S, which is 157, divide by radical 15. Plug it in the calculator again. So open the parentheses, 724 minus 900, close the parentheses, divide by, open the parentheses again, 157, divide by the square root of 15. Exit the square root, close the parentheses, and enter. So we get minus 4.34. So again, we're going to go to the chart. Minus 4.34, you're going to be somewhere here. So the t-stat, minus 4.34. And obviously it's within the reject zone, right? So step 4, reject 80. Step 5, if you reject, yes, you have evidence. Now, are you supporting the claim or not? You have to go back. You rejected 80, so you're not supporting the claim. You see, you are supporting H1 and H1 is not the claim. So do not support the claim. And that's all. I think that's the end of this question.